Hello guys, this is Rajat and this welcome to this video solution of uh, Buckbeak's Night CTF. Okay, looking at this challenge, we see this title and description. Buckbeak was an animal character. I don't know what kind of character he was from Harry Potter, and we have a .wav file here too. Okay, basically, when I started solving this challenge, I thought this is a voiceover for interference, and I don't know why I'm out of breath right now. Okay, yeah. So searching Bucking. Okay. You'll see the hint too. Hint was very helpful because then only I realized it was a music cipher. Upon searching the hint, we see someone called John Bucking. He was a German, I think, composer of some sort, and he created this music cipher on his own. We see a website that shows us later how it is used for encoding certain words into musical notes. This was a Bucking music cipher website from, well, you can see the URL. You will have to visit it. As you can see here, different letters are provided with different note combinations. This is like really complex if you look at it from like a newbie's point of view. Okay, so basically it was inputting like a word and it converts into a musical sheet, different notes combination for each word, and when we play it, music kind of plays. Okay, now when we play in the starting of that particular audio file, if you see the starting and the end, will sound a lot similar to starting of the original file. Okay, so this confirms that the file is actually encrypted in Bucking cipher only. Now, working on what I did after, that was converting the .wav file into .midi file. MIDI file, as you will have to research about that. I spent like 6 hours researching it, and then only I was able to solve this challenge. Um, so MIDI file I converted into, and I was able to create a music sheet on MuseScore, but it was really complex. So I was not able to, individually decipher which music code defined which subject, which alphabet and so on. So what I did was identify these, you see below N there are 4 scores, and below I there are 5 scores. These are different notes. Okay, using Medo function in Python. Yeah, see, there are different scores for different alphabets. You can download these um, into a MIDI file, and then I used a code here. What I did was input A, B, C, D, E, F, G up to Z, and then download the MIDI file of that, and then use that MIDI file to assign each letter with their own note combination. If you see here, I used tune under score 868.midi file, which contained all the alphabets in it. And how I divided it was like if you see A has first five, first five are ignored because it is just introduction, and last seven are ignored because it is just the ending. So A has next five, then B has next five, and C has. Similarly, I divided all these notes like into different alphabets. Um, then further, like you see, yeah, I divided it here. Upon running this program, I was able to get specific note combination of different letters, as you can see here. Now, further working on like how to verify this, if it's actually working or it's just a fake. I made another .midi file. Uh, Initially, well, I thought that .wav file, this description only contained the flag. So I used the flag format, NITE here. Sorry. This .midi file, and then I used this particular data, and then I fed into this .midi file into this particular code. If you if you see, I run the bucking.py file. It gives me NITE, the words that inputted, it's encrypted into a .midi file, which I was able to decrypt correctly using the data I had created earlier. Okay, so this verified my process. Now I only had to decrypt the original .midi file. Okay, now okay, so changing the name for the MIDI, like original MIDI file. Uh, you see, there's the actual content string in it. Now, if you see here, there is actually, if you can make some sense out of it, but you can't make like total full sense of it. This was due to multiple letters being very similar to each other in notes value. If you see U and P are very similar. Why? Because for the three notes of U are very similar to the first three notes of P. S and A were very also very similar because some notes in them were actually the same. So the code was like really confusing, but you had to make sense on your own. There was another error. If you notice here, there is L here. There shouldn't be an L here. It was like continuously arising. And okay, yeah, see here. If you see here, same index, two values, A and F. Same index, two value, P and U. Okay. Uh, L was an error. I don't know why it kept arising because I tested it on different strings too. Now seeing what the string means actually is if you ignore A, use. If you ignore U, phrase. Proof fans read the book. They have to, I don't know why the P was not working in this particular scenario. As to hear, they have to read the book to hear something deep. Okay. Now, here I thought that this was the final flag. I tried a bunch of time to input this into the flag value too, but it was not working. So I opened a ticket with the author of the challenge, and what he told me was that this was not the final flag. This was a passphrase, password, something. And for that something, I had to read into this thing only. So what I did was, I like, if you see it carefully, you see the deep word in it. Okay. I used Deep Sound tool, the software. What it does is, it uh, hides or it like hides different files into one another type of audio file. Okay, so I use the original .wav audio file, bucking.wav, into deep sound, and when I tried to open it, it asked me for a password, and we already had the password. I never really knew that I needed a password. By mistake, I made a password. Now this says just the string only is very obvious. True fans read the books. Okay. So I input the password, proof, and read the books, and it accepts it as it is, and gives us two files from. We can extract them, but as I've already extracted them, I will not do it so here. I'll show you what those files have in them. So this disclaimer file is pretty much an actual disclaimer file. Uh, it is not related with the challenge. And there is this screech.mkv. It is a mkv Matrovska video file. Now, upon watching this file, I noticed that uh, uh, if you see here, the subtitles are very suspicious. Like these are not errors. Errors would be very random, repeating and not like yeah, this is not random. Does not look random. Okay. So what I did was I looked into its metadata and I found two .ots files in it. OTF files are basically the font files that are used. Different font files are there. There is the one type is .otf. So what I did to extract them was use mkv extract. If you see the GitHub of that author, so he has an uh, online version of it too. You go over there, you upload your file, and you will be able to extract the metadata files in it. Like there was one .as file too, which contained the subtitles for this, and there were two .odf files. So those OTF files were very important because it was really hard to extract them in any other way. Now this Buckbeak OTF you see, well, it's just obvious that this contains something. There is something. I open it and I see here. This will be the format for our flag or the font for our flag. So we go into OTF viewer. I have an OTF viewer open here, and I upload the buckbeak.otf file on it so that I can, you know, do something with it. At least read it, what happens with it. Yeah. And now it's uploading. Love to see what it contains. Okay. So this is the default phrase that the website uses. It converts into the actual font that the font file supports. Okay. Now what do we input here so that we get our final flag using the font? Remember the subtitle that I was talking about? That is what we'll use here. I extracted a .srt subtitle file and I used it. This is the final flag that we get. I was really proud of myself because it took me like 6, 7 hours to like continuous 6, 7 hours of sitting on my ass on this laptop and working on it. And I have an end term exam tomorrow. Thank you.